Automobiles that run on gasoline are a problem due to global warming, but in order to solve this problem, electric vehicles are attracting attention. However, due to problems such as battery charging and the use of large amounts of energy to manufacture batteries, there has recently been a movement to reconsider it. On the other hand, fuel cell vehicles that use hydrogen and magnesium as fuel are being considered. There is also the problem of storage of hydrogen, which requires further study. Magnesium fuel cells are expected to be put to practical use in magnesium production. Although there is a similar problem, I would like to propose a Stirling engine fueled by magnesium. The Stirling engine was invented in 1816 by Robert Stirling, a Scottish minister. As a heat engine, it is theoretically predicted to have the highest thermal efficiency. The efficiency is calculated as 1 minus low temperature part divided by high temperature part. If the absolute temperature of the low temperature part is 293 degrees 20 degrees Celsius, and the absolute temperature of the hot part is 1273 degrees 1000 degrees Celsius, the efficiency is 77%. This is a very large efficiency compared to 30 to 40% of gasoline cars. The history of the development of the Stirling engine is old. Philips produced half a kilowatt around 1950 and 120 kilowatts around 1972. In the US, the P75 achieved 65 kilowatts in 1975, and in Japan, Aisin Corporation achieved 52 kilowatts in 1978. In the United States, NASA is conducting a number of experiments with cars with a 75 horsepower, 56 kilowatt Stirling engine. Over the course of 1 year, they conducted a long-term driving test of 9,000 miles and 14,000 kilometers, and determined that there was no problem. However, in this case, fossil fuels are used to heat it. This was announced in 1992, but a YouTube video was published in 2012. The heating source can be solar heat, nuclear power, or anything else, and it has mainly attracted attention for space use. Since the piston motion is changed to rotational motion, it can be used either in the mode of driving the wheels like in a conventional gasoline car, or in the mode of generating electricity by turning a generator. Here, we propose a method in which magnesium reacts with water and burns it to generate a high temperature. An experiment in which 1200 degrees Celsius was achieved by magnesium combustion was published in Applied Physics Letters, a prominent international journal of applied physics, by Yabe in 2006. At 1200 degrees, the theoretical efficiency of Stirling engine is 80%. On the other hand, the efficiency of a gasoline engine is 30 to 40%. This is a thermal efficiency, but there are also other problems with mechanical efficiency, such as piston friction. This is not a problem for car companies, as it is a mechanism that is already used in gasoline vehicles. Since magnesium is a solid, if it is used as fuel, the question is whether the fuel can be supplied continuously. Yabe used a mixture of magnesium and water in a ratio of 1:2 as fuel. This is fluid, so it can be transported through the tube. The video is this experiment. 2 valves control the fuel injection. Magnesium and water are poured through a tube attached to the top of the burning chamber. 2 valves are used to prevent it from blowing upwards. When the upper valve is opened, fuel is supplied from the fuel tank installed at the top and accumulates in the pipe between the 2 valves. In order to prevent flowing back into the fuel tank at high pressure, close the upper valve and then open the lower valve. Along with the fuel input, you can see that it reacts violently. Now it's just a matter of how cheaply magnesium can be produced. Seawater contains 1,800 trillion tons of magnesium, and we are proposing an efficient way to extract it. Experiments have shown that the seawater desalination system manufactured by Yabe et al. Can produce 43 liters of distilled water per 1 kilowatt-hour of thermal energy. It contains 56 grams of magnesium. Distilled water is quite expensive, but if you sell it for 100 yen per liter, 1 kilowatt-hour will sell 4,300 yen. This energy can be obtained from anywhere, but if you simply use conventional electricity, the profit will be 430 times the price of electricity. On the other hand, it has been proven that a 1 kilowatt-hour laser can smelt 73.8 grams of magnesium. Since the efficiency of semiconductor lasers is currently around 50%, the power required to produce 1 kilogram of magnesium is 27.1 kilowatt-hours. It is better to use wind power, solar power, and geothermal power generation, but even if you use ordinary electricity and use 10 yen per kilowatt-hour of electricity, the price of 1 kilogram of magnesium will be 271 yen, which is about the same as the current selling price of magnesium. To get the same price as gasoline, it has to be half cheaper. That's where distilled water from seawater comes in. By combining distilled water and magnesium, the price of magnesium is still comparable to that of gasoline due to the sale of distilled water. Of course, with the development of various technologies, it will be possible to achieve this with a laser alone.